In this video I'm going to talk through the 5M2, 5M3 mock paper that sat last week, 25th of February. This is a combination of two papers, both the calculator papers from a particular set of mock exams. The 5M3 paper is a little bit different, but the majority of questions, almost all the questions, are exactly the same, so this video should work for both classes. Question 1. Oliver records the distance from London to each of 8 cities in the USA. He also records the time taken to fly from London to each of these cities. The scatter graph shows this information, so there we are with the 8 cities and the distance and the time taken. Chicago is a city in the USA and is 4,000 miles from London, and we can see that there is nothing marked that's 4,000 miles from London. By drawing a line of best fit, find an estimate for the time taken to fly from London to Chicago. So first of all, we need to actually follow the instructions and draw the line of best fit. So I can't demonstrate this very well with this software, but I can do a bit better than that. I can do roughly, it's meant to go through, it doesn't have to go through any of the points at all. It should have roughly the same number of points above and below the line, a similar sort of distance, and follow the main gradient of the pattern formed by these points. So trying to estimate for Chicago there, I'm going to use 4,000, draw that across to the line. It's a good idea to actually draw these to make sure that you get the marks, so draw on your readings onto the graph to make sure that you get those marks. That ends up being 490 minutes, making sure that you read every square as 5 minutes and not 10 minutes, because there are 10 squares between 450 and 500. The mark scheme will accept anything from 480 to 500 in there. Why is this only an estimate in part B? Lots of reasons could possible here. You can say my line of best fit may not be entirely accurate. Or there are only 8 points in the sample. Or you could discuss the fact that there is no reading for anywhere close to Chicago, close to 4,000 miles. So if you mention that there's a gap in the graph and we don't know what happened in that graph, anything to suggest that it's not an accurate representation, it's only an estimate, it's only guesswork. Part 3, calculate the gradient of your line of best fit. Again, it's important to mark on the diagram. This is worth 2 marks, so in order to get both marks you need to show some working. Generally what I would do is just to choose something easy from the scale. So I'm going to say within the time of 100 minutes, so between 500 and 600, I'm going to take those readings and I'm going to do change in y over change in x. So my change in y is 5050, and my change in 5050 minus 4100 over 100. That was 600 minus 500 on the graph. That's 950 over 100, which is 9.5, so my gradient is 9.5 in this case. Make sure you're using the units marked on the scales and not just counting squares. Counting squares would give you a very different answer. Give an interpretation of the gradient of your line of best fit. It's distance divided by time, and therefore it's a speed calculation that the gradient gives. So that's what's needed for the answer. It's speed of travel, or just speed, in miles per minute, and even that bit isn't necessary to get the mark, but it's worth writing down the details in case they're on the mark scheme. Question 2. Write 168 as a product of its prime factors. So product of its prime factors showing working. So we need to factorize this first of all. You can use your calculator, but I'm just going to keep dividing by 2 to begin with until I get a number that I recognise as a multiple of something else. So that's 6 sevens, and 6 can be split further into 2 and 3. So these are all the prime factors. But I need to write it as a product, not just a list. So a product of its prime factors means it has to be in the form of either 2 times 2 times 2 times 3 times 7, or even better, 2 cubed times 3 times 7, because that's more efficient. Find the highest common factor of 168 and 180. Well, I've already worked out the prime factors of 168. If I hadn't, I could just do a list of all of the factors of both of these numbers and look for the highest one. But seeing as I've already done some of this work, I'm going to use the method that compares prime factors of these. So I'm going to do a prime factorization of 180 in the same way. So I get 168 as 2 times 2 times 2 times 3 times 7, and 180 as 2 times 2 times 3 times 3 times 5. And I look for the factors in common, because if I multiply those together, they will give me the highest common factor of these two numbers. So HCF is 2 times 2 times 3, the common ones. 12. Question 3, here are two rectangles. All measurements are in centimetres. That means our answer is probably going to be in centimetres. The area of rectangle A is equal to the area of rectangle B. Work out the perimeter of rectangle B. So with any of these algebra questions, we want to first of all use this statement to create an equation. So the area of rectangle A is 2.5 times 4x. It's equal to the area of rectangle B, which is 7 times 2x minus 3. Remember the brackets there. It's you're going to make sure the 7 is multiplied by each of these. So doing the calculations with this, that leaves us with 14x minus 21. 10x equals 14x minus 21. I'm going to balance this by subtracting 10x from both sides, leaving me with 0 equals 4x minus 21. And then add 21 to both sides, giving me 21 equals 4x. Divide by 4. So when I divide both sides by 4, that gives me 5.25 equals x. I haven't finished answering the question yet because I need to work out the perimeter of rectangle B. So rectangle B is 2x minus 3 plus 2x minus 3 plus 7 plus 7. That gives me 4x minus 6 plus 14, which is 4x plus 8. And if x equals 5.25, that gives me 4 times 5.25 plus 8, which equals 29. So the answer, the perimeter of B, is 29 centimeters. Question 4. The diagram shows a fair-sided spinner. Fair four-sided spinner. Hazmeet is going to spin the spinner twice. Complete the probability tree diagram. So the probability of it landing on A on the first spin is 3 out of the 4 possible ones, and landing on B 1 out of 4. Second spin is exactly the same probabilities. So on the second spin, 3 out of 4 for landing on A, 1 out of 4 for landing on B. So this is going to be the same for the whole diagram, which is perhaps deceptively easy. So we're not working out the calculation of landing on A and then landing on A yet. That comes in later. All we're doing is the probability of each branch and making sure that everything on the branches adds to 1. So every pair of branches adds to 1, the probabilities. Work out the probability that the spinner will land on A on the first spin and on B on the second spin. So that is this path, land on A and then land on B. In order to do that, we need to do the two probabilities multiplied together. So you always multiply along the branches. That gives you 3 out of 16, which is the answer here. Better to give an answer in fractions, much better than decimals in this case. Question 5. Calculate the value of s when a is 8 and b is 10. So this should literally just go into your calculator. I'll leave pi as it is at the moment. We've got b squared, 10 squared, minus a squared. So that is pi squared times by 100 minus 64. You can do all of this in your calculator if you like. So that is 36 times by pi squared. Make sure you square the pi before multiplying by 36 because of the laws of indices. So that gives you, I would always write this out in full off the calculator so that you can see where it's come from, or at least more than you need to, more figures than you need to, and give your answer correct to 3 significant figures. So we now need to just look at the first 3. That is 3, 5, 5. In question 6, Mariam is trying to expand and simplify n minus 2 squared, and here is her working. So she correctly puts them out in brackets, n minus 2 times n minus 2, n squared minus 2n minus 2n minus 4, and here is the problem. So Mariam's answer is wrong. Find her mistake. Minus 2 times minus 2 equals 4, not minus 4. Just make it clear what the correct answer should be, as well as where the error has occurred. And I've also ringed where the problem is here. Second part of the question, Shona has to draw the line with equation y equals 3x plus 2, and here is her line. Explain why Shona's line cannot be correct. So we can say that it's to do with the y-intercept here. Y equals 3x plus 2 should cross the y-axis at 2, and we need to show why we know that this isn't the case here, and that it's because it's below the x-axis. So I'll say, but this line has a negative y-intercept. There are lots of different ways of explaining this, but it is important to show that it's the negative thing. It's the fact that it's below the x-axis, or that it's in the negative region, that tells you that it's definitely not 2. Because otherwise we've got no scale on this, and if it was something above the axis like that, anywhere above the axis would be fine. We wouldn't know for sure that it wasn't the right line. But because it's below the x-axis where it crosses, we know that that can't be an intercept of plus 2. So that's an important part of that answer. Question 7. Only blue vans and white vans are made in a factory. The ratio of number of blue vans to the number of white vans is 4 to 3. It's important we know that there are no other colour vans involved, because it says write down the fraction of vans that are blue. That is 4 in every 7 are blue. Blue is the first number. So that is 4 out of a total of 7 vans. For blue vans, the number of small vans to the number of large vans is 3 to 5. So when you've got 8 blue vans, 3/8 of them are small. Work out the fraction of the number of vans made in the factory that are blue and large. So large vans that are blue are 5/8 of 4/7, which we can write as a multiplication. 5/8 times by 4/7 of is the same as multiply by. So that gives us 20 out of 56, which can be simplified to 10 out of 28, can be simplified further to 5/14. Just going to check that on my calculator. Yep, 5/14. Question 8. The diagram shows a quadrilateral JKLM. Work out the size of angle KLM. So I'm going to mark that in first of all. That's the thing I'm trying to find. I'm just going to mark it X. Give your answer correct to 3 significant figures. So in this triangle, I don't have enough information yet to be able to answer the question. I would need at least 2 sides of the triangle to be able to do that. It is a right-angled triangle, so I can use SOHCAHTOA once I've got enough sides. This is also a right angled triangle, so the first thing I'm going to do is work out the length of km using Pythagoras' theorem. So 7 squared plus 4.5 squared equals km squared. So km equals the square root of, just doing that calculation, 7 squared plus 4.5 squared, square root of 69.25. So km equals 8.32165, etc. I'm going to leave that on my calculator and my calculator memory, and I'm going to mark it on the diagram so I'm clear about what's going on. I now have two sides of a right angled triangle. I've got the side that is opposite to the angle, and I've also got the hypotenuse. So if I look at SOHCAHTOA, it's sine that I want to use, the one with the opposite and the hypotenuse. So sine of x equals the opposite side, the one that's in my calculator, over the hypotenuse, which is 15. So on my calculator I do that division. So x is sine to the minus 1 of that thing exactly, 8.32 ... over 15. So I do sine to the minus 1 of that answer, and I get the answer 33.695 degrees. It asks for 3 significant figures, so that becomes 33.7 degrees. Question 9 asks for the reciprocal of 5. That literally just means the flipped version. You might want to write 5 over 1 and then flip it to 1 over 5, but all that needs to be on the answer line is 1/5 here. Part B, use your calculator to work this out. You might want to do it in stages so that you can show some working. It's worth 2 marks, so it's probably worth getting the marks for this bit as well. So I'm going to write it out as the cube root of... I'll do tan 60 first, multiply the answer by 5, and then add 1 to that, which is 9.6602 ... And then I'm going to do the cube root of that answer, which is 2. Oh, it does want me to write all of the answers from the calculator display. No rounding at the end. So 2.129754359. Question 10. In 2016, the population of the UK was 6.5 times 10 to the power of 7, so standard form there. Laura wants to calculate an estimate for the population of the UK in 2020. She assumes the population increases by 0.6% each year. Using Laura's assumption, calculate an estimate for the population of the UK in 2020. So 2020 is 4 years after 2016. So I'm just going to write that down first of all. 4 years, 2017, 18, 19 and 20. 0.6% each year means we're going to multiply by 1.006. If the 6 was there, it would be 60%. 6 was there, would be 6%. 0.6%, we have to put the extra decimal place in. So 4 years. So I'm going to multiply her number using the percentage multiplier method by 1.006 to the power of 4. And since this is a estimate, I don't need to give it to its full accuracy. So I end up with 66574,096.24. I would write that number down because it's the number that comes off my calculator, but as an estimate, all I really need to put is probably just 3 significant figures would be fine for that. So 6.66 times 10 to the power of 7, or you could write it as 666,000,000. That's the same number. Or you could write that in standard form as well, or just as that, but for an estimate you definitely wouldn't want to have a decimal, because it should be a whole number of people at least. Okay, so for part B, we've got Kieran also assumes that the population of the UK increases by 0.6% each year. He says that it will take over 80 years for the population to increase by 50% because 50 over 0.6 is 83.3 recurring. Kieran's method is wrong. Explain what is wrong with his method. So to get this mark, you need to explain, you need to understand what he's done here, which is he said that if it's 50% divided by 0.6%, that is going to be over 83 years. But what he hasn't taken into account is that the value of 0.6% is going to be increasing, the actual value, because that's how compound percentages work. So I'm just going to mention he has not taken account of compound percentages. I could explain that also as his calculation assumes that the actual increase is the same each year. But it isn't. But it will be more each year. So that's two answers there. It's only a 1-mark question, but it's important to show that you understand the principle and you've looked at his calculation and tried to understand what he's saying with that. Assuming that the population of the UK increases by 0.6% each year, back to the original assumption, show that the population of the UK each year forms a geometric progression. So a geometric progression is one in which you're multiplying by the same thing each time to get from term to term, so that you end up with a progression that is always multiplied by the same thing. So there's a common ratio in that progression. So we could write that either as the common ratio is 1.006. That would show that it was a geometric progression. By actually writing this down, I've shown that I understand what a geometric progression is, which is what this question is really about. The other thing that you could do is actually use the values that you were given at the start. So we've got 6.5 times 10 to the 7. So 6.5 times 10 to the 7 gives me 65 million. And show the actual values of increasing it by a multiple of 1.006 each year. So that gives me 65390,000. So this would also get the mark, this method. There should really be a concluding statement in this as well. If I've done that, that would be enough to show that I've got the geometric progression, but there also should be each term is multiplied by the same number to reach the next term. So, geometric progression. Question 11. In a sale, the price of a TV is reduced by 25%. So, reducing something by 25%, you would be multiplying by 0.75. A week later, the sale price of the TV is reduced by 15%. If you're reducing by 15%, you would multiply by 0.85. After those two reductions, the price of the TV is now £293.25. what was the price of the TV before the sale? So this is reverse percentages. We look at what we would have done forwards, which is multiplied by that and then by that, and we do the reverse. So 293.25 divided by 0.85 divided by 0.75. That's going to make the answer bigger, which is what we want, because if you divide by something that's less than 1, you get an answer that is bigger. So 293.25 divided by 0.85 is 345 divided by 0.75, which equals 460. And then you would probably want to check this in an exam by doing exactly the same thing, starting with the 460 and just checking that when you go forward, whatever method you want to use for 25%, 15% reductions, you would then end up with the number that has been given in the question. Question 12, AB is 3, 2, and that's shown on the grid. BC is minus 1, 4. On the grid, draw BC. So B goes from B to C, so this is where we need to start. Minus 1 means it's to the left 1. 4 means it's up 4. 1, 2, 3, 4. So BC is this one, and the key thing with vectors is that every line needs to have an arrow on it to show that it's BC and not CB, and it also needs to lead to the point C, because it needs all of those things to make it the vector BC. So any of those missing, and unfortunately you lose that mark. Part 2 of this, AD equals AB minus BC. On the grid, mark with a cross the position of D. So we can do this in two ways. We could do it with the actual vectors themselves. AB minus BC equals 3, 2, minus 1, 4, and you get a mark for this working. 3 minus 1 is 4, 2 minus 4 is minus 2. So if I do that from A to D, that is 1, 2, 3, 4 across and 2 down. And it said to mark it with a cross, so I'll do that and label it D to make sure it's there. The other way to do it, if it's AB minus BC, is to say, well, if that's AB, then do CB from there, so or BC backwards from there, which is 1, 2, 3, 4 down and 1 across. And that would take you to D as well. Question 13, a complicated ratio question. Anna and Bill share some money in the ratio 2 to 5. Anna gets £, Bill gets £. Carl and Donna share twice as much money as Anna and Bill share. They share the money in the ratio 3 to 1. Carl gets C pounds, Donna gets D pounds. Find the ratio of Anna's amount to Bill's amount to Carl's amount to Donna's amount in its simplest form. For this, I'm going to actually just put in some numbers. I'm going to say assume. There are ways of doing this with fractions and algebra, but I think when you've got ratios compared to each other, it's probably going to be easier just to use actual numbers. So I'm going to say assume that they share £7 between them, and then see, can I split that in the ratio 3 to 1? And I can't, because I can't divide 7 by 4. So I'm going to try £14. Again, it's a multiple of 7. Again, I can't divide that by 4, so I'm going to say they shared £28. Well, actually, they can share £14, and then the £28 is the twice as much that Carl and Donna share. So let's say that Anna and Bill share £14. That means Carl and Donna are sharing £28, which can be divided by 4. That means Donna gets 28 over 4 is 7, so she gets 7. Carl gets 3 7s, 21. Anna, if they're splitting £14, Anna will get £4, and Bill will get £10. £7 is 2 to 5, £14 is 4 to 10. So overall, ABCD is 4, 10, 21, 7. And I actually can't simplify that because 7 doesn't go, it can't be divided by 2. And none of these can be divided by 7 apart from that one. So overall that is my simplest form, 4 to 10 to 21 to 7. Again, there are ways of doing that with algebra and fractions, but I think it's going to be easier just to use the numbers involved and just assume that there's a number to get the marks there. Question 14, expand and simplify. All you need to do for this is expand the first double bracket, or any pair of double brackets would work, and then multiply everything by the next bracket. So I'm going to do x plus 2, x plus 8 first of all, which is x squared plus 2x plus 8x plus 16, and then I want to multiply that by x minus 4. I'm actually going to simplify that first, x squared plus 10x plus 16 times by x minus 4, just collected the like terms in the middle. And then I'm going to need 6 terms to come out of this, 3 things times by the first thing, 3 things times by the second thing, and I need to really make sure that happens. So I'm going to start with the x squared. X squared times x is x cubed, minus 4x squared. Then 10x times x is 10x squared plus 10x squared, minus 4 times 10x is minus 40x. And then I'm going to do plus 16x minus 4 16s, so minus 64. Putting those all together, I've got x cubed minus 4x squared plus 10x squared is plus 6x squared, minus 40x plus 16x is 24x, so minus 24x minus 64, and I just need to make sure every time that I've got 2 terms that are in x squared, 2 terms that are in x, that can be simplified into those 4 different terms, x cubed, x squared, x, and the constant number term. Question 15, here is triangle PQR. The length of QR is 60% of the length of PR. Find the value of sine QPR. Angle QPR is here. I was going to call that x. Give your answer correct to 3 significant figures. Again, this is a proportion problem, and it's going to be made simpler if I just choose a length that works for this. So I could choose, if QR is 60% of PR, I could choose those. Obviously that's going to be easier to write that as 6 and 10, or even 3 and 5. Any of those will work. I then sine QPR is opposite over hypotenuse. I don't have the hypotenuse yet. That is going to be opposite is QR over PQ. So I need to find PQ. I'm going to choose these as my easiest numbers, 3 and 5. So PQ squared equals 3 squared plus 5 squared, which equals 34. So PQ itself is going to be the square root of 34. So sine QPR is the opposite, 3, over the hypotenuse, root 34. And it actually doesn't want angle QPR, it wants the value of sine QPR, so I don't actually have to do the inverse sine with that. I literally just type into my calculator 3 divided by square root of 34, and that gives me the answer of 0.514. As always, I should probably write down the full answer, 1.44957. So it's 0.514, correct to 3 significant figures. Question 16. Here are 5 graphs. Each graph shows either direct proportion or inverse proportion. We know that direct proportion means it will go through 0, 0, which all of these do apart from that one. And here are some graphs, equations that go with them. And this one is all just about recognizing a cubic from its turning points. So if I was to do that, the obvious ones, the cubic from its turning point is that one, E. This one you may not know, the square root graph, so we'll come back to. A quadratic graph always looks like a parabola like that, so that is D. The inverse proportion graph is this one that doesn't go through 0, 0, so that is A. And y equals kx is a straight line graph that goes through the origin, so that's B, leaving you with C, and that is what a square root graph looks like. That's just doing the positive square root there, which is what happens if you type a square root into your calculator. Question 17. For any 3 consecutive whole numbers, prove algebraically that the largest number and the smallest number are factors of the number that is 1 less than the square of the middle number. So this is a very complicated setup. Very complicated to read through the words. But we can start off with any 3 consecutive whole numbers, so I'm going to call them n, n plus 1, n plus 2. It does need to be proved algebraically, so numbers are not going to help with this if you've demonstrated it with numbers. So prove that the largest number and the smallest number are factors of the number that is 1 less than the square of the middle number. So I'm going to just start with square of middle number. Is n plus 1 squared, which is n plus 1 times n plus 1, which is n squared plus n plus 1, n squared plus 2n plus 1. And then if I think about what I've been asked here, the largest number and the smallest number are factors of the number that is 1 less than the square of the middle number. So I've done the square of the middle number. If I subtract 1, I get n squared plus 2n. So that's the minus 1 bit. N squared plus 2n can be factorized to n and n plus 2. Which is these factors are the largest and smallest number. So if I've started with my 3 numbers, that's the middle number squared, and that shows n plus 2. These factors are the largest and the smallest number. So I've shown that the largest and the smallest number are factors of the number that is 1 less than the square of the middle number. Question 18a. Show that the equation x cubed minus 3x squared plus 3 equals 0 has a solution between x equals 2 and x equals 3. I'm just going to start off by substituting these values in. When x equals 2, 2 cubed minus 3 lots of 2 squared plus 3 equals 0. It doesn't equal 0. It equals 8 minus 3 times 4 is 12, plus 3. So that is minus 1. When x equals 3, 3 cubed minus 3 lots of 3 squared plus 3 equals, you could do this all on your calculator, 27 minus 27 plus 3, so equals 3. So there is a change in sign. You can say this. It goes from when x equals 2, it's a negative solution, negative result. So the solution for equals 0 must be between x equals 2, be between x equals 2 and x equals 3. Part B, show that the equation x cubed minus 3x squared plus 3 equals 0 can be rearranged to give this. This just needs to be very clear what's happening in each stage. So we can see that we've got a 3x squared minus 3 on that side, which means that the x cubed bit is going to be the other side. So I'm going to, first of all, add 3x squared to both sides. You don't actually have to write the arrows on the side, as long as you get the line of working that's correct in the middle. Subtract 3 from both sides. That gives you x cubed equals 3x squared minus 3, and then you cube root both sides. And that gives you x equals the cube root of 3x squared minus 3. Part C of the question, starting with x0 equals 2, that's x0 equals 2, use this iteration formula, xn plus 1 equals the cube root of 3xn squared minus 3, to find the value of x2, corrected 3 decimal places. So to show that you're doing this properly, you need to start off with your x0 equals 2. Your x1 is the result of doing this to the number 2. So xn is 2 squared minus 3. Just put the 2 in there. So that is the cube root of 2 squared is 4, 12 minus 3 is 9, cube root of 9. So that is 2.08008, etc. And x2, you're going to do the same thing to this. It's the cube root of 3 times that thing squared, minus 3. So in my calculator I'm just going to square my previous answer, times it by 3, minus 3 from the result, and then cube root that answer. And that gives me 2.153015, etc. So 3 decimal places is 2.153. That's 3 decimal places, not 3 significant figures. Question 19. A factory makes ice cream tubs in 2 sizes, small and large. The tubs are similar in shape. That means that one is an enlargement of the other. The height of the small tub is 5 centimeters. The volume of the small tub is 150 centimeters cubed. And the volume of the large tub is 500 centimeters cubed. Work out the height of the large tub, correct to 3 significant figures. So in this we need to know that the scale factor, there's a cubic scale factor which links the volumes, there's a squared scale factor that will link the areas, and there's a linear scale factor which is what we need that links this height to this height. So first of all, volume wise, I've got to go from 150 to 500. What is the factor that, the scale factor of that? I can do 500 divided by 150 is 3.3 recurring, or I'm going to put it as 3 1/3. So times it by 3 1/3 to get from smaller volume to larger volume. So if I was doing area scale, well, I'll just go, that's the cubic, that's the cubed version of the scale factor. So if I want to go from 5 in linear, just a straight line length, I'm going to go 5 to my answer by timesing by the cube root of my previous answer, cube root of 3 1/3. So on my calculator I can cube root my previous answer. That is 5 times by 1.493 something. Leaving it all on my calculator, that gives me 7.469007, which is the height that's missing there. So work out the height of the large tub, correct to 3 significant figures. It is 7.47 centimeters. Question 20 is a transforming functions question. On the grid, sketch the graph of y equals f of x minus 1. So if you remember the rules, inside the brackets means that you're going to translate it in the horizontal direction, in the x direction, and it means that you are going to go the opposite to what you'd expect from that. So it's going to be 1 to the right. So that is going 1 to the right there, that's going 1 to the right there, that point goes 1 to the right there, That point goes one to the right there. Just marking everything that goes through the corners of the grid. Try and draw that in nicely. It's not perfect, but it would get the mark that. If you're unsure of this, you could also see what the result is. If you can't remember the rules, you could say f of x before, when x was -1 before you got that. Now it's as if when you put -1 in, you're actually going to put -2 in. -1 minus 1 is -2. So when you put -1 in, you get the same result as you did before when you put -2 in. And when you put 0 in now, you get the same result that you did when you put -1 in before. So that's why this works. That's why that notation actually means it shifts one to the right. The graph of y equals f of x has a turning point at the point -1, 1. It's this point here. Write down the coordinates of the turning point of the graph y equals f of -x plus 2. So f of -x, it's flipped it in the horizontal direction over the x-axis. So that would take it from there to there. And then you're plussing 2, so you need to move it up 2 in the y direction. It's outside the function, so that needs to go up 2. Which means that that point has flipped across the axis to there and then gone up 2, and it's now in the position 1 across 3 up, 1, 3. Question 21. The diagram shows a sector of a circle of radius 9 centimeters. The sector has a perimeter of 25 centimeters. Work out the value of x in the circle to correct to one decimal place. So first of all, we need to work out the value of this arc here. There is nothing to do with area in any of this question. Area isn't mentioned. So first of all, I'll do 25 minus 9, which gives me 7. So that is 7 centimeters on that length there. If I think about circumference of a circle, which is what the arc is a part of, the arc is a part of the circumference, is pi times by the diameter, which in this case is, the diameter is 9 plus 9, that's 18 pi. And the thing that we're looking at is a proportion of that circumference, an angle out of 360 of that circumference. So this fraction of the circle times by the true circumference, which is 18 pi, gives us the number 7, and we can now solve this to work out what x is. So first of all, divide by 18 pi, that gives me x over 360 equals 7 over 18 pi. And then multiply both sides by 360, so x equals 360 times by 7 over 18 pi. And if I put all of that into my calculator, it gives me 44.56. So correct to one decimal place. Full answer is 56338, etc. So correct to one decimal place, that is 44.6 degrees. And the final question, functions composite function question, tells us that f of x is x cubed, g of x is the function 4x minus 1, find f of g of 2. So you always do the inside function first. So g of 2 is 4 times 2 minus 1 equals 8 minus 1, which is 7. First mark for just getting 7 as g of 2. F of g of 2, if g of 2 is 7, then we need now f of 7 is 7 cubed, and that gives us the answer 343. And then we're told that h of x is the same as f of g of x. We've just done f of g of 2. Find an expression for the inverse of h of x. So first of all, I'm going to find an expression for f of g of x. So f of 4x minus 1 is 4x minus 1 all cubed. And now I need to find, and that is h of x, is f of g of x. So 4x minus 1 cubed, and I need to find, if h of x is that, I need to find the inverse function of this. So what I can do is say that y equals 4x minus 1 cubed, and start trying to make x the subject of this formula. So cube root both sides. Cube root of y is 4x minus 1. 4x minus 1. So cube root of y, cube root of y plus 1 is 4x, and divide my answer by 4. Cube root of y, I've done the same thing again. Cube root of y plus 1 over 4 equals x. And then for the final stage of this process, remember to remove the y and replace it with an x. So the inverse function is cube root of, done the same thing again, cube root of x plus 1 all over 4. The other way to look at this is to think of the order that things have happened to x. So you can say x has been multiplied by 4 to give you 4x. It's then had 1 subtracted from it to give you 4x minus 1, and it's then been cubed. Quite hard to write a cube sign, so I'm just going to write cubed. And if we go in the inverse operation with the inverse order with the inverse operations, we'd go cube root. So that gives us the cube root of x. Then 1 was added, so you get cube root of x plus 1. And then the inverse operation was divided by 4. Divided by 4, that gives us exactly the same answer, cube root of x plus 1 over 4. I'm just going to write that properly. Cube root of x plus 1 over 4. And that is the end of the paper.